guys, Shishir here. This module is about demystifying the clients and servers. So far we have understood what a computer is and how it is connected to a network, the communication, the IP addresses, etc. Now let's talk about the much hyped about servers. What are they and how are they different from a PC, which we all see or we have commonly used? Here is what we are going to cover in this module. We are going to define servers and clients. We are going to look at the operating systems which are available. We are going to define operating system, applications, and subsystems. We are going to understand high availability. And within high availability, there is an application level high availability, there is a network load balancing, and there is clustering. So, a lot of concepts, once again, theoretically. Okay, so let's begin by defining the servers and clients. It's a much hyped topic, and I remember when I knew nothing about servers, it used to sound so serious and complex when someone said server. Let me demystify it today. Usually, when someone says a server, an image pops in our head, and that looks like this. Overly complicated cables and stuff, and these racks and these multiple units, etc. We are here to simplify. Let's look at a Google definition of a server first. In computing, a server is a computer program or a device that provides functionality for other programs or devices, called as client. This architecture is called as a client-server model. A single overall computation is distributed across multiple processes or devices. Okay, ignore the last part of the definition. Let's keep the definition only to the point. A server is a computer program or a device. It could be a computer program or it could be a device that provides functionality. It is providing functionality to other program or devices called as client. So somebody who is providing functionality to another client. A server provides functionality to the client. Or there is another definition. A person or a thing that serves. Or a computer program which manages access to a centralized resource or a service in a network. I would like to go with the definition number one. A person or a thing that serve. Anything which serves is a server. So if you really break it down, a server is anything which serves, and those who receives the service is a client. A father brings money to the home, which family uses. Father is a server and family is a client. Mom makes the food, which everyone eats. Mom is a server and everyone, including father now, who brought the money, is a client to this service. I'm teaching you here and you guys are learning. I'm a server, you are a client. Anything which produces a service to someone is a server. Similarly, a computer providing a service is called as a server and the computer receiving the service is called as a client. Now we also need to understand that a computer which is a server in one scenario can be a client in another scenario. Like I mentioned above, father when he brings the money to the house, he is a server. But when he eats the food made by another server which is mom, then he is a client. So ultimately they are all computers, but generally because the service which a server has to provide is like more like 24/7 and a lot of users or clients are relying on them to use them. So the servers are built with a better hardware. Like they have a faster moving hard drive or they will have more processor or bigger processors. They will have a motherboard which is bigger and it can accommodate more RAM or PCI cards. But at the core, a server and a computer, a laptop, will pretty much have the same architecture. Same processor, same motherboard, same RAM. Just the quality of the hardware which is used in a server, just because they have to provide a 24/7 service, is a lot higher. So we don't have to get terrified of a server. Ultimately, a server will have the same hardware as a computer and it works on the exact same logic as a regular computer. Let's talk about the server operating systems. There are so many operating systems which you can install on a server. Let's begin with the Google definition of operating system. An operating system is a system software that manages computer hardware, software resources and provide common services for the computer program. So it's a software which is used to manage the hardware of a computer and provide services to the client. Firmware is also a kind of operating system. Firmware is usually referred to a piece of software which is used to manage a smaller piece of a hardware and not a whole computer. Like there is a firmware in your TV, there is a firmware in your router or modem. Every smart device which you see around yourself has some kind of a firmware in it. A firmware which has too many features and functionality will be referred as an operating system. So big computers which you see, they have the capability of installing more applications on top of them, and they have a capability of providing more functionality and a better interface and a grander gesture about them. They are operating system. But what about the smaller interfaces which are available? Maybe the software which is installed in your printer, the software which is installed in your television, the software which is installed in probably even the smoke alarm in your house. What are they? They are some if and why and for loops kind of a logics which are built into a program, and they are put into your other hardwares. Now these restricted functionality hardwares whose purpose is very specific, restricted functionality software, sorry, whose function is very specific to a limited device, are called as firmware. And similarly, a firmware, when it has too many features and too many functionalities, and if it can accommodate other applications to be installed on top of it, then it will be called as an operating system. Like Android is an operating system, iOS is an operating system. When we used to remember the phones in the olden days, they didn't have the functionalities of installing any more applications on top of them. They were just there so that the hardware of the phone can function, and those were firmwares. They were not operating systems. So let's look at the operating system. There are multiple companies which are providing operating system: Apple, Microsoft, Google, Linux, Unix. There could be more which I have not listed here, like Nokia, Symbian, BlackBerry. All these were operating systems. Apple, if we divide, it has got a client operating system, it has a server operating system, and it has a mobile operating system. So the client operating system is Mac OS, which comes in all the Macintosh computers. And the server operating system is the Mac OS X server. It's not there anymore. It used to be there until very recently. It was not used in the market a lot extensively, so I'm good. I'm happy that they discontinued it. Then the mobile operating system, the iOS, which you see in the iPad and the iPhones, it's there. Google has the Android and Chrome. Chrome is more than a browser now. It is coming as a full-fledged operating system on some of the notebooks. So Google Chrome notebooks are available. So that's the operating system. And then they have Android. Android is the mobile phone operating system, which you see in a lot of devices now. There are even Android TVs, and there are even Android media systems, and apart from Chrome as well, the Android is being used extensively. So these are operating systems from Google. Now, our bread and butter, Microsoft. Microsoft operating systems are divided into Microsoft Server and Microsoft Client. Microsoft Server started from Server NT, that was the first operating system. Then after that, there was Server 2000. Then there was Windows Server 2003, and shortly after, Windows 2003 R2. Then we got Server 2008, and then shortly after that, we got Server 2008 R2. Then we got Server 2012, and shortly after that we got Server 2012 R2. Then we got Server 2016, and now we have also received Server 2019. So these are the Microsoft operating system. On the other side, we have got the Microsoft Client operating system, which started with Windows 95, then Windows 98, then Windows ME, then Windows 2000. And then we got Windows XP, which came along with Server 2003. Then we got Windows Vista, which came along with Server 2008. Then we got Windows 7, which came along with Server 2008 R2. Then we got Windows 10, which came along with Server 2012. So these are the various Microsoft client and server operating system. You need to understand that there are two different categories of operating systems. Some are server and some are client. This is also a good question for interviews, and you should remember the name of all the operating systems of the clients and the servers. Now we are getting into an interesting topic, and that topic is basically something which is referred during the infrastructure talks every now and then. And these are the words called as operating system, application, and subsystem. And we need to understand what is the difference between them. Now that we understand an operating system, you already understood that it's something which makes your hardware go and you can install further applications on it, and it's basically the heart and soul of a computer system. I want you to understand a couple of other terms which are used a lot in the industry, and they are close to each other in terms of meaning. Operating system, we already discussed, it's the first super software which you put on your computer hardware, and it serves as a platform for all the other softwares which are put on top of it in future, like Windows, and you install Microsoft Office on it or Adobe on it. Applications, what are applications? These are the softwares which you put on top of operating system to perform a specific function for the user. So application example could be Adobe, Acrobat, or AutoCAD, or there are so many applications available, Microsoft Office Suite, etc. So those are applications. Application software. Application software is a program or a group of programs designed for end user. Example of an application include word processor, a spreadsheet, an accounting application, a web browser, an email client, a media player, a file player. So basically what I told you, those are the applications. What is a subsystem? Subsystem, as the name suggests, is also an application installed on top of operating system, but usually it is such an important application that it actually defines the role of the machine itself, like Microsoft Exchange, or IIS, or web server, or Citrix, or remote desktop services. The dictionary definition of subsystem looks like this: a self-contained system within a larger system. So a larger system is the operating system, and a subsystem is Microsoft Exchange. But the fact is that when you install a Microsoft Exchange on a Windows 2008 R2 server, you don't call it a Windows 2008 R2 server anymore. You call it an Exchange server. Or if you install web services on a Windows 2012 server, you don't call it a Windows 2012 server anymore. You start calling it your web server. Or if you have installed Citrix on any such server, you will call it a Citrix server. Or if you install remote desktop services on it, you will call it a remote desktop server. So the point is that subsystem is so important. It is not like Microsoft Office or Adobe. It is such an important application which basically renames your whole server, and it is usually a single application which is installed on that server, and the sole role of that server is to service this application and for this application to provide services to all the clients. Hope that makes sense to you. Now that we have understood the operating systems, and we have understood the applications, and we have understand the subsystems, I want to explain some more terms to you, which are high availability and load balancing. What is HA, or high availability? Expectation when a business buys a big expensive computer called as a server is to perform a task that it will never go off and will provide the service 24/7. But in reality, that's not true. Server, like any other computer, have too many variables which can interrupt the service. Like occasional OS or server failure, your server can fail, it can shut down. Or even more probable is a power failure. Maybe you will just lose the power. It could be, or a network issue, or maybe a human error. Just an admin logged into the server and he did something silly and the services went down. So a business expects the server to be always available, but in all possible reason or ways, it's very well possible that the server will go down for one reason or another. Now, in order to maintain business expectation, and despite of all these possible failures, we have come up with a term or a feature called as high availability. So high availability is a feature which can fulfill the expectation of the business that a service will remain available all the time, irrespective of what happens to a particular server. In fact, in a lot of businesses, in services where a service provider is providing a service to a client, they talk about the SLAs, the service level agreement, which they do with the client. They talk about the service availability. They don't talk about the hardware availability. In the service level agreements, it is agreed with the client that the service should remain available 24 cross 7 or with the 99% uptime. Nobody cares about the server. Even if the server goes down and if the service is available, client don't care about it. So the business expectation is that service should remain available, even if the server fails. And in order to make those expectations a reality, we use something which is called as high availability. So let's learn what this is about and how does it function. So how does an HA function? In this scenario, there are two single point of failures, server and network. So typically, a HA scenario would look like this. So this is not an HA scenario. There is a server and there is a network and the client is using the service of the server. Now, how can the client stop receiving the service? If the server goes down for any reason or if the network goes down. There are two variables in this particular example. A client is out of the picture because nobody is ever questioning the client. It is about the server to be able to provide the service. The client can go very well home. Nobody is going to ask him. So there are only two variables, the server and the network. So in this scenario, you have two single point of failure. And a typical HA scenario would look like something like this. So what I have done, I have added multiple servers here and have added multiple networks here and I have the same client. Now in this scenario, even if one network goes down, the other network can pass the information. Or if one server goes down, the other server can service the client. But unfortunately, it's not as simple as just drawing some lines on a paper to get the high availability working. Because it's not just about your understanding, it's also about the machine's understanding that it has been configured in high availability. And it needs to understand that how it is supposed to behave when it is in high availability. So let's find out what kind of a HA you can configure in a server environment. There are two types of high availability. There is an application level high availability. So there are some applications like Active Directory servers or Exchange servers which have a built-in HA capability. These applications are designed in a way that they're able to redirect the client requests to each other and are able to pick up a request which was getting handled by a peer server without the client knowing that a new server is now processing the request. So Active Directory by design, you can have multiple Active Directory servers and as long as even one or two of them are available, the client will never notice that the services have went down. And an individual server has no role. All the servers are equally capable and they can provide the service. So this is an application level high availability. The other level of high availability is created when the application itself is not capable of providing the high availability. And such high availability we get via the Microsoft cluster or failover clustering. There are certain applications like remote desktop connection broker, which are designed to keep HA in mind. But they have too many out of the application component like backend databases, some external functionalities like a network driver or an IP address, which cannot be controlled by the application itself. For such application, Microsoft Server has a built-in capability called as MS Cluster, which help group together many different components in order to achieve application level high availability. So what we are trying to say here is that Active Directory is by default an application which has all of its component under its own control. So it is able to provide a very highly robust and highly available system quite easily. And you will learn about it when we learn about Active Directory more. But as compared to that, a service like remote desktop services, it is dependent on too many external variables which are not part of the default application for it to be able to provide high availability. So it is not in the capability of this application itself to provide an application level high availability because there is a network IP address which is concerned and there is a backend database which is concerned and there are other functionality which are concerned. So in such cases, what we do is that we install something which is called as a failover clustering on a server. And we create a logical group of a cluster where we provide a group of resources, and we define the relationship between these resources for the services to fail over from one point to another. Again, it sounds complicated, and it is indeed complicated. But the point here for you to understand is that there is something called as a high availability, and there is an application level high availability, or there is a failover clustering level high availability. There is another type of high availability which we'll learn in the next section, but the point and the core understanding which you need to get here is that what is high availability and why do you need it. The third level of high availability is called as a network load balancing. This is the dumbest high availability option where multiple servers are installed with same application and configured to behave the same way. So Microsoft network load balancing is really simple. Each application server is installed with an individual application, and they are configured exactly the same way. But these applications themselves don't know that there is any kind of a high availability. What they do is they go ahead and just put a device in front of these servers, and this device receive all the requests for serviceability, and then this device makes sure that the server behind them is live and it can service the request, and it keeps providing the request to one of the server. Both servers are totally unaware of that there exists another server which is doing the same thing. They just act on the request which is presented to them. So we use Microsoft NLB in a lot of situations. It is a poor man high availability, as we call it. Microsoft NLB feature is installed on all the servers. So how we basically configure Microsoft NLB is that we install the NLB feature on all the servers. All the servers are joined to an NLB cluster from NLB console. So don't confuse the word cluster with the failover clustering cluster. It's just an NLB group or a NLB cluster, actually. That's what the name is. And this NLB cluster is defined a virtual IP, which gets binded to all servers network adapter. So this NLB cluster acts as the front-end device which is receiving all the requests, and then it is sending it to both or more than both, whatever the number of nodes in your cluster is, to all the servers behind it. Now all the requests are directed to this virtual IP, and as long as the server behind it is alive, that means it's responding to the ping request, NLB cluster will keep sending client requests to it. But if the server stops responding to the keep alive signal, the ping request, then the client will not reach to it. The reason we call it dump is because it's solely dependent on keep alive signal. So there happens a situation where the actual application on the server stops responding. But just because server is alive, the client will keep getting redirected to it and hence failing. So Microsoft NLB is another type of load balancing, which is the dumbest of all three of them because the application itself is never aware that it is being made highly available. There's just a front-end NLB node which redirects the request to all the clients which are behind it, and each client serves the request like it is the only one to service the request. It doesn't have any idea that there is any other NLB or high availability configured with the other nodes. Alright, so this brings us to the end of this module, and here is what I want you to do. If you have a Windows 10 machine, go ahead and install Hyper-V role on it. If you don't have a Windows 10 machine, then maybe go ahead and reinstall the operating system on your Windows laptop to Windows 10, because before that you will not be able to install Hyper-V on a Windows 10 machine. Or you can install a Windows 2008 or a Windows 2016 or 2012 operating system on your machine. If you don't know how to install an operating system, then please go ahead and refer to some YouTube video, or you can ask me as well. I'll be happy to help you. But primarily, you have to go ahead and install the operating system on your machine. And after that, you will install the Hyper-V role. You will create an internal virtual network on the Hyper-V. You will create 2 virtual servers on it and 1 virtual PC on it. You will be defining processor, RAMs, and IP address of these machines. Install Windows 8 or Windows 10 on the PC, install Windows Server 2012 on the two servers, install failover clustering component on the two servers and get acquainted with the console, install Microsoft NLB on two servers and create a NLB cluster, making the two members provide virtual IP to it. Try pinging the virtual IP and see it keeps responding, and turn off all the three machines for now. So I know this sounds very complicated. So what I'm going to do is I'm going to create a separate video for you showing you how exactly to do these things so that you can just follow the video and do these things along. Okay, so that's it for the end of this module, and I will see you in the next module now. Thank you so much, and keep doing the activities which you have to do, because I know this is getting more and more complicated, but if you keep following the activities, it will be interesting for you and you will keep learning more and more. A lot of things are a little high end if you are just trying to get an entry level job, but if you are really trying to become a senior level engineer, if your focus is to become that, then it's good that you learn these things. All right, so I will record another video showing you how to do this. I have to tell you that I personally use a Mac, so I would not be able to install Hyper-V on my machine. So what I do is I have a Microsoft Azure account. You can also sign up for a Microsoft Azure account, by the way. And I use their trial account to create my machines and set up my machines. I have a Microsoft partner account with them as well, so I have a little more flexibility than a typical person would have with them. But yeah, having said that, you can always sign up a trial with them and you can get access to the Azure panel, and then you can create the machines there. So don't worry, I'm going to show you all that in another video, and you can see how to do it, and then you can perform all these activities. All right, thank you. Bye bye. Take care.